Okay guys, today we're going to discuss 1.2, solving rational equations. The unit numbers got mixed up a little bit because we added some new material for this year's college prep, took off a few other materials. So that's why this got kind of mixed up, the number. It's 1.2, don't think that it's, like from quarter one. Anyways, so I have here today, I have my notes of course, and then I'm going to have my graphing calculator and my cell phone Desmos. So those are the two items I'll be using today. So a rational equation just means an equation with a fraction. Rational expression, fraction. That's a fraction. So any equation with a fraction is a rational equation. Now sometimes the x will be in the denominator, sometimes it'll be in the numerator, sometimes it'll be in both. So there's various things you can do depending on where the x is located. What you want to do, your key goal here, is to clear the fractions, and sometimes it's easier than others. So you want to clear the fractions by multiplying both sides of the equation by the least common denominator, or in other words by the number in the bottom or the item in the bottom that we have. Then we're going to collect like terms, in other words combine like terms, isolate the variable, and solve. And we have to check for extraneous solutions. So for example, if I was looking at this equation, x cannot be 0. So if I came up with a value that said x was 0 when I solved this by clearing the fractions, I would know that that's an extraneous solution. Sometimes that can happen based on how the equations are set up. Alright, so what I like to do, here's a couple examples here. What I like to do is I like to look at the denominators and I like to multiply by the denominators. So here I've got a denominator of a 5 and a denominator of a 4. I don't really like to get a common denominator before I multiply. Some teachers do. What I like to do is I usually just like to multiply by both. So I'm going to times everything here by 5. And when I mean everything, I mean both of the expressions here and then the expression here on the right. So when I times this first expression by 5, the x minus 2 over 5 by 5, this 5 and this 5 are going to make a 1. They're going to reduce each other. So that expression becomes an x minus 2. The next one, however, the 5 needs to distribute because 5 and 4, 5 doesn't divide evenly by 4. And I don't want to use a fractional expression here. So I'm going to put this 5 on the top. I'm going to distribute it to the top. So that's going to become a 5x minus 25 now over 4. And some of you say, well, that just made the numbers bigger. Yes, it did. So yes, that's going to happen. It's going to make the items bigger when you multiply, if you have multiple expressions. Now, I've got a 4 in the denominator of this one. So I'm going to multiply every expression here by 4. This negative 10 was 2 times 5. 2 times 5. So now I'm going to take everything times 4. 4 times x is 4x. 4 times minus 2 is minus 8. Now here again, this 4 and this 4 are going to reduce, because 4 divided by 4 is 1. So that was the reason we multiplied by 4. That was why we wanted to multiply by 4. So that will reduce. It'll leave me a negative 5x. Now here's the tricky part. A positive 25. Because this minus in the front of this expression, minus x minus 5 over 4, it applies to the 5x and to the 25. So that 25 becomes a plus 25. The minus 10 becomes minus 40. So that's how I prefer to do this. Now I could have done this all in one step if I had multiplied by 20. So if I'd said here instead of 5 and 4 separately, I could have multiplied by 20. 2 times 20 is 40. 4 divided into 20 is a 5. So that would be 5x minus 25. And 5 divided into 20 is a 4. 4x minus 8. I just prefer to do it as two separate steps. Multiply separately. Again, it's your option, whichever way you want to do it. Now we're going to combine like terms. 4x minus 5x is negative x. Negative 8 plus 25 is plus 17 equals negative 40. 17 from negative 40 is negative 57. So x here is 57, according to my answer. Alright. Now I can check that solution by putting it back in for x and making sure that it ends up being a negative 2. So how would I check my solution? I would take my calculator, either Desmos or a regular calculator. I'd take 57 minus 2, that's equal to 55. So I'm going to divide that by 5. 55 divided by 5. So that's 11. I'm going to take away 57 minus 5. So that's 52 divided by 4. And we get negative 2. So you can see that that's a solution. That's our solution. 55 divided by 2. 55 because 57 minus 2. Minus 52 divided by 4 is equal to negative 2. So that's how I would check this. And in a minute here I'll show you how to type these in, or in a few minutes here I'll show you how to type these in and get the solution from the calculator. Alright, so for this one, this x minus 2 is a denominator. It's the only denominator, so that's what I'm going to multiply by this x plus 2, sorry, not x minus 2. So that's going to reduce out the x plus 2 in the bottom there, and the x plus 2 in the bottom there. So what's going to happen is we're going to no longer have an x plus 2 in the denominators here. And now I'm going to solve this equation. So to solve this equation, I'm going to bring this x over to the 2x, this 1 over to the 3, so that it's equal to 0. And then I'm going to attempt either to factor, or if it does not factor, I'm going to use the quadratic formula. So x take away from 2x is x. Negative 3 plus 1 is negative 2. So now I'm looking at this, I'm asking myself, does this factor? And it does. It says 0 is equal to x plus 2 times by the quantity x minus 1. That's the factors here. So we have x squared and minus 2 and then plus x. So now I'll solve each of these separately for my two solutions. X plus 2 equals 0 and x minus 1 equals 0. So x is equal to 1 and x is equal to negative 2. Now I need to check my answers. So 1, if I put in 1 for x, it's going to be 1 minus 1, 0 divided by 3. And then here it's going to be 0 divided by 3. That works. So this one's a good solution. I'm going to circle that one. That one's good. Again, I can use the calculator. 1 minus 1 is 0 over 3. 1 squared plus 2 is 3 minus 3, 0 over 3. Now the negative 2, the issue is when you put negative 2 in for x here, it yields 0 in the denominator, in the original equation. So this x minus 2 is extraneous. So in other words, this one I'm not going to circle, it's extraneous, it's not a real solution. And when I mean not real, I mean it's not an actual solution. I don't mean it's complex. So in other words, that is not a solution of this equation. It's not a solution at all. It's not complex, it's not a solution at all. So that is not a solution. So you can cross this out when you get this one, or you can just label it as extraneous. Definitely do not circle it as an answer though. It is not a solution here when you solve this equation. Okay, so there's that set. So that set represents, the basic concept of getting rid of denominators. And it can be more difficult, it can be more simple on some equations, so some of these are harder than others. So like when I'm looking at this one, these two, they seem really simple, but perhaps they have something, a trick to them. So like look at this, it's got an x on the bottom. That's what I'm going to multiply everything by. And I mean everything. So every expression here, there's three expressions. There's the x, the 12 over x, and the 1. There's three expressions or three terms. I guess I could say terms. And do the same thing on this one, multiply everything by x. So I'm going to multiply every term by x. So here, x, I'm going to times it by this x. It's going to be x squared. Now when I times the x by the 12 divided by x, that reduces. It gets rid of the x there. So that becomes just minus 12. And then I times the x by the 1, that'd be equal to x. I'm going to bring this x over. Again, my goal here is to either factor or use the quadratic formula. So if it's factorable, I want to factor. If it's not, I'm going to use quadratic formula. So I'm looking at this, I'm saying 4 and 3 would make a 1x. An x minus 4 and an x plus 3 equals 0. So that would mean that x is equal to 4 and that x is equal to negative 3. And so I check the 4. 4 minus 12 divided by 4 is 3 is equal to 1. That's correct. I check the negative 3. Negative 3 minus 12 divided by negative 3 is negative 4. So negative 3 plus 4 is also 1. These are both valid answers. They're both good and valid answers. So I'll circle both those. Same thing happens here. X times x is x squared. X times 6 divided by x is 6. and then x times 5 is 5x. Move the 5x over, x squared minus 5x plus 6 is equal to nothing. So we're going to have x plus 6 and then x minus 1. I didn't use 3 and 2 there again because I need to make negative 5 when they add, but I also need to make positive 6. Oh, I should have used 3 and 2. My bad. The 6 and 1 is not going to work because that's negative 6. I'm going to need to use negative 3 and negative 2 if I want that to work properly. Negative 3 and negative 2. So x minus 3 is equal to 0, so x is 3. And then x minus 2 is equal to 0, so x is 2. And again, I need to check my work. 3 plus 6, 2, so 3 plus 2 is 5. And then 2 plus 6 divided by 2 is 3. 2 plus 3 is also 5. These are both valid answers. X can be 3 or x can be 2. Alright, example 3 has two denominators. X plus 4 is one of the denominators, x plus 1 is the other. So again, what I like to do is I like to multiply by both of them, just in a separate step. So I usually choose the one that has multiple of the same if there's two of the same to start. So I'll multiply by x plus 4 here. I do that because that makes it a little simpler, not much simpler, but a little bit in terms of the multiplication. So this doesn't have the x plus 4, this first term. So I'm going to have to take this x times the x plus 4. So that's going to yield an x squared plus a 4x. X times x times 4. And it's still going to have that x plus 1 in the bottom. I didn't get rid of that x plus 1 because I didn't multiply by it. But these other two terms, these x plus 4s, they're both going to be gone in the bottom, and the top is just going to be the leftovers. So plus 3 equals x plus 3. Like so. Now here, I can multiply by that x plus 1, but what I've noticed right now, looking at this, is look, there's a 3 on both sides. And it's not divided by anything. These can be reduced out. So what I'm going to do is I'm going to be a little tricky here. I'm going to say take the 3 from the 3, and this is going to make it so I only have 2 terms instead of 4 terms. So it's going to make my equation simpler before I multiply by that x plus 1. Now that is not required, that step. It just makes it simpler when you multiply the whole thing by x plus 1, because now this term, the x plus 1 will reduce and you'll just have the x squared plus 4x. And on the other term, you only have one other term to multiply by the x plus 1. So that would be x squared plus x. So there's what I have. And then I'm looking at this and I'm saying, well, our next step is going to be canceling out these x squareds. So x squared take away x squared is 0. And then taking x from 4x is 3x. So I'll take x squared from each other to reduce them out. And then I'll take x from 4x to make 3x. 3x is equal to 0. So what I have here is that x is equal to 0. I only have one answer. I do need to check my answer and make sure it's correct, but I only have x is equal to 0. So if I put 0 in for x, 0 divided by anything is going to be 0 unless it's 0. So 0 divided by 1 is 0. Okay. 3 divided by 4, so 3/4 on the left. The 0 plus 3, 0 plus 4 is equal to 3/4. X equals 0 is a valid answer here. And there's actually only one valid answer on this one. Why is there only one? Well, that's because the x squareds canceled out this time. Unlike in the one above, the couple above where the x squareds did not cancel out. So there is no set amount of solutions with these. Sometimes you'll have 1, sometimes you'll have 2. If I made a really tricky one, you could have up to 3 answers. So just keep that in mind. It doesn't have to have 2 answers. It doesn't have to have 1 answer. It could have 3. It just has as many answers as you have when you finish factoring here, if it has multiple factors. Anyway, so that's my approach on that question. And again, I'll show you a graphing approach too in a second here when we get to the ones on the calculator. And you can do all these on the calculator. You don't have to do them by hand. Okay, this one is very important with the ones that factor in the denominators to factor them. So this x squared minus 9, I'm not going to multiply by this. The reason I'm not going to multiply by it is because it factors into an x plus 3 and an x minus 3. It's very important you attempt to factor anything that's not a linear term. in the denominators, because that will make it so that you can do the questions easier. So now I'm recognizing here, I'm just going to multiply by both the x plus 3 and the x minus 3. I can do them as separate steps or as a single step. Again, I prefer separately. So I'll start by multiplying by the x plus 3, which this one has it already. So it just cancels that one out, leaving us 2 over x minus 3 for that term. This one does not have the x plus 3, so I'm going to multiply that by the 5. So plus 5x plus 15 over x minus 3. And this one has the x plus 3, so I'm just going to make that into a 3, because that denominator will reduce out with that x plus 3. And now I'm going to multiply everything by x minus 3. Both these first two terms have the x minus 3, so I can just reduce them by eliminating it. And then this last term doesn't have that x minus 3, so I'm going to have to multiply that. 3x minus 9. Alright, get the x over here, 2x, combine the 2 and the 15, 17. 2x plus 17 is equal to negative 9. Move the 17 over to negative 9, and you'll get 2x equals negative 26. Divide it in half, you'll get negative 13 for our answer here. Okay, so again, I can check my work by plugging that negative 13 back in, and I should get the same item on both sides. So 3 divided by negative 10, so negative 3/10. This should also be on the left, 3 divided by negative 10. And I can verify that using Desmos or using a calculator. So 2 divided by the quantity, negative 13 squared minus 9 in that parenthesis, plus 5 divided by the quantity, negative 13 minus 3. Oh, and I need the parentheses around the 13 here, otherwise it's going to square the 13 and then negate it. Negative 13 as a quantity like that. So that's negative 3/10 when I type that in the calculator here. Which we already decided on the left. On the right, it's the same thing, negative 3/10. 3 divided by negative 13 plus 3, negative 3/10. So you can check on the calculator and make sure your answer is correct. Okay. One word problem here, and then we're going to do the calculator. Have you shown I'll show you how to do it on the calculator questions. So a boat travels 246 miles downstream the same time that it takes to travel 180 miles upstream. Alright, so the distance it travels downstream, 246. Alright, so our formula here for distance, D equals RT, is our formula for distance. And then our distance downstream, downstream is 246, upstream is 180. Alright, so our rate, when we're traveling upstream, it's going to be whatever rate we have for the boat, its actual speed. We're going to take away the speed of the rate of the stream, 5.5. So this will be the actual speed, or the rate, minus 5.5 miles an hour. And this will be the speed plus 5.5 miles an hour, because the stream will push with it. So what I'm going to do is I'm going to take two distance equations and set them equal to each other for the time, because the times are equal. So in other words, time is equal to distance divided by rate. Because what I'm trying to find for is the time, and then I'm going to find the speed of the boat. Or I could do it the other way around, and I could do rate is equal to distance over time. Rate is equal to d over t, since the rates are the same. Alright, so what do I have here? I have a distance and a rate, so I should probably use d divided by r equals t. Why should I do that? Well, because that's going to be simpler, because d divided by r equals t. These are the two items I actually wrote down here. I didn't write down the time because I don't know what the time is. The time is the same though. So I'll take my distances, 180 over and 246 over. Remember, the time is the same, so that's why I can set these equal. The speeds are just different. So 180 over the speed minus 5.5 is equal to 180 over the speed plus 5.5. All right, and then from here, I can solve this by, you guessed it, doing what we did up here, multiplying by each denominator separately. All right, so I'll multiply both sides by s minus 5.5 first. So I'm going to take 246 times 5.5 to start this out. 246 times by 5.5 is equal to 13,530. So on this right side, I'm going to have 246 s minus 13,530 divided by s plus 5.5 equals, and that's going to be 180 on the left now because I multiplied by its denominator first. Now I'm going to multiply by s plus 5.5 to get rid of this other denominator. So I'm going to take that 180 times 5.5. 180 times 5.5. Nope, not 5.5. 990. I think I multiplied that one wrong. Let me look at that again. 246 times 5.5. 1353. I don't need that zero. 1,353. Alright, so I'll have 180s plus 990 equals 246s plus 1353. Minus 1353, sorry. Minus. That's my sign. Alright, so now I'll combine like terms. 1353 plus 990 is 2343. And then 246 minus the 180 is 66. We'll type it in to make sure we don't make a mistake though. 246 minus 180 is equal to 66. And then finest, last thing we gotta do is take 2343 divided by 66 to get our speed, 35.5 miles an hour. Alright, and we could also go through and we could find the time that we spent on the water now, but that was not asked. It was asked just to find the speed of the boat in still water. So in other words, I did not actually find the time. I only found the speed of the boat for this question. Cool. Alright, so for these last two, I'm going to show you how to do these on the calculator. Again, we're using Desmos. So this is going to be a little bit different than perhaps what it shows here. So what I want to do on the calculator, if I'm going to do these on the calculator, is I want to graph both sides of the equation as separate expressions. So x, I'm going to use a parenthesis here on the x, x plus 2 divided by, again on the bottom, 1 minus 2, whoops, minus, I wanted a minus sign there, minus 2x in that parenthesis. Now the nice thing about Desmos is it does have an equal sign, so I'm not sure what's going to happen here if I put this equal to 5. Let's see what happens. Yeah, I thought that might happen. So it doesn't actually give a clear answer here. So what I'm going to do is I'm just going to keep that first one the way it is, the left side of the expression, and I'm going to use another expression here, x equals 5. X equals 5. Or it can be y equals 5. So what I want to do here is basically I want to figure out where these two cross. And where they cross is right there, where that line was going in. And it's not actually graphing that one. Oh, hold on a second. It's not actually graphing it. Interesting. So I want to figure out where it crosses here at y equals 5 and this other line, this other expression, right here at this x value, because that's my solution. But it's not actually doing what I thought it would do, the Desmos. So what I'll do here with you then, I guess, is do what I did at the start. And then this line right here, this line is your solution line, and it's not actually giving me the value of the line here. But that line is a solution, and its value is right here on the paper here. I have it on the paper, 0.2727273 is the solution for this equation. It's not actually giving me though that number. So maybe no, I don't want to do that. Don't want to do that. Don't want to do that either. It's the first time I've tried to do something like this on the Desmos. So yeah, it might take me a bit to figure out what we're doing here, how we're going to make this work. So I've graphed that. There we go. So what I had to do here is I had to type in y equals 5 to graph them together. Because what I need is, again, where these two cross. There's the item we're looking for, 0.273 on the graphing calculator. So in order to make that work again, what you're going to have to do, type in the left side of the equation. And if the right side is just a number, type in y equals that number, because we want the graph of that. We want y equals 5. And it didn't understand when I just put 5 there. It didn't understand I wanted y equals 5. So you'll have to put the y equals with it. Now that will work with all the other expressions we did today, all the other equations. So we could type any of these other ones in here, and I'll type one in a minute after I do the next one. So here we're going to do x minus 3. So I'll go back here and I'll change this to a minus 3. And then x plus 2. Oops. X plus 2. And again, for that right side of the expression, I'm going to have to put y equals 1 divided by 5, 1/5. Oops, not like that. Look at that. That'll work. Alright, and again, what I'm looking for is where the lines cross, which is going to be right in there. At that point, 4 1/4. 4.25. X is equal to 4.25. Again, so what I did is I just typed in both expressions. What x minus 3 over x plus 2, and this right side was just a number, so I had to type y equals 1/5 to do that one. These other ones we did before, let's see, this one probably took the longest to do by hand. So like if I were to do that one, I'll type in the left side. So 2 divided by x squared plus 9 plus 5 divided by the quantity x minus 3. There's that one. And then the other side would be 3 divided by x plus 3. 3 divided by the quantity x plus 3. So there I've got that typed in, that example 4 from before. And what I can do again is I can just look for where they cross in terms of the solution. So I'm thinking it crosses at negative 13. So I'm going to go over here and yep, there it is. There's the crossing of it at negative 13. The calculator does have some round off error, negative 12.897. So the calculator does give some round off error. The phone calculator does. Probably on the computer will give you a better estimate. So that will work on the other ones as well, graphing. In terms of what I intend to test with these, I don't intend to test the ones that you have to graph. I intend to test more of these type, where you multiply by the denominator to get rid of it and then solve. So that's what I intend to do with these. Alright, so the next page is your homework there, page 167, 168. Thanks for coming. Good luck.